At the fringes of science and mystery lies a peculiar claim that refuses to disappear: the Hutchison Effect. Named after Canadian experimenter John Hutchison, this phenomenon supposedly involves a collection of bizarre and physics-defying effects: objects levitating, metals fusing without heat, and materials turning into a kind of jelly. These effects, Hutchison claimed, were achieved using a strange combination of electromagnetic fields, radio frequencies, Tesla coils, and static. So let's ask, could this be real science? Or is it an illusion born of misunderstood experiments and amplified by internet myths? Let us begin with the reported phenomena. In his cluttered home laboratory during the 1980s, Hutchison filmed a series of experiments where metal bars appeared to levitate or melt into wood, wires curved midair, and steel became soft and gelatinous. He claimed these effects were due to interference patterns between high-voltage fields, essentially that overlapping electromagnetic waves could cause unknown energetic phenomena in matter, possibly linked to anti-gravity. This sounds extraordinary, and as Carl Sagan said, extraordinary claims require extraordinary evidence. But here's the problem. No independent scientific team has ever reproduced these results under controlled conditions. Multiple investigations, including one by military observers and journalists, noted that Hutchison's lab lacked detailed controls, documentation, and repeatability. Critics argue that the effects may be nothing more than video trickery, electromagnetic interference with camera systems, or misinterpretation of phenomena like arcing, heating, or resonance. Despite this, the videos remain widely shared and inspire curiosity even among some engineers and fringe researchers. So, what physical mechanisms did Hutchison propose, or what did others suggest? Some theories invoked scalar waves, zero-point energy, or resonant field harmonics. Scalar waves are hypothetical longitudinal waves not recognized in mainstream electromagnetic theory. Zero-point energy, the lowest possible energy state in quantum mechanics, is a real concept, but harnessing it to levitate objects or alter materials remains purely speculative. The US military, notably in some fringe circles, was rumored to be interested in the effect for non-conventional propulsion, but no official program has confirmed this. Let us ask a key question. Could electromagnetism, in principle, affect gravity? According to known physics, no. General relativity and electromagnetism are governed by entirely different fields. While both obey field equations and can influence space-time, no experimentally verified mechanism links EM interference to gravitational manipulation. However, strong EM fields can cause mechanical effects such as vibrations, corona discharges, and even object movement, especially if light objects are subjected to static or RF fields in unpredictable setups. These real effects can mimic levitation under certain filming angles, leading to misinterpretation. Now think about this analogy. Imagine you're watching a magician levitate a spoon. The visual is compelling, but unless you understand how the trick works, you might think it's supernatural. In science, we must demand reproducibility, measurement, and peer review. Otherwise, we're dealing with illusions, not discoveries. So where does this leave the Hutchison effect? Despite its dismissal by mainstream science, the phenomenon hasn't been fully debunked in the sense that no lab has reproduced and falsified it with the same equipment. But in science, the burden of proof lies with the claimant. Without replication, measurements, or theoretical foundations, it cannot move from anecdote to scientific knowledge. Let's be fair, some historical breakthroughs were once dismissed as pseudoscience. Plate tectonics, meteorites, and ball lightning were controversial before being understood, but they survived scrutiny and were eventually confirmed. The Hutchison effect, by contrast, has not evolved in decades. It remains a series of unverified videos and unverifiable anecdotes. The Hutchison effect serves as a fascinating case study in fringe science. It sparks imagination, touches on hidden desires for anti-gravity and free energy, and reminds us how easy it is to be seduced by extraordinary visuals. But without experimental clarity, theoretical grounding, or reproducibility, it remains a scientific mirage. The Hutchison effect refers to a group of phenomena allegedly discovered by John Hutchison in the late 1970s, including levitation of objects, fusion of dissimilar materials, spontaneous fracturing of metal, and the softening or jellification of solid structures. These effects were reportedly produced using a chaotic arrangement of Tesla coils, static electricity sources, and radio frequency RF generators operating simultaneously. Hutchison claimed that interference patterns and resonance among these fields caused the observed anomalies. No peer-reviewed scientific publication has validated these claims, and the descriptions often lacked quantitative detail or reproducible conditions. Hutchison demonstrated objects such as wrenches and metal rods rising off surfaces or appearing fused to wood in his home laboratory. Like watching a magician perform levitation without showing what's behind the curtain? Impressive, but unverified. Mainstream physics does not support the idea that electromagnetic fields can negate or manipulate gravity in the way Hutchison described. General relativity models gravity as the curvature of spacetime caused by mass energy, and it does not include direct coupling between gravitational and electromagnetic fields. While EM fields can exert forces on charged or magnetic materials, they cannot alter gravitational mass or spacetime curvature under normal conditions. Some speculative models in unified field theory have proposed weak EM gravity interactions, but none are experimentally verified. No laboratory has ever levitated neutral, non-magnetic materials using electromagnetic fields without involving airflow, charge, or magnetic repulsion. Like trying to lift a bowling ball using only light. It sounds elegant, but physics. Electromagnetic resonance involves the amplification of energy when a system is driven at its natural frequency, and it is well established in physics and engineering. Hutchison claimed that his apparatus created complex field interactions and standing wave patterns that could disrupt matter at the atomic level. In practice, multiple high-frequency and high-voltage devices operating together can generate unpredictable interference, arcing, or dielectric breakdown. While these may cause mechanical vibrations or heat-induced deformation, they do not explain phenomena like cold fusion of metals or gravity anomalies. Without precise measurement, such effects may reflect known resonant behavior, misinterpreted as exotic physics. Hutchison's experimental setup was chaotic and unshielded, making it vulnerable to spurious currents, RF crosstalk, and electrostatic discharge. Like playing several musical instruments in a storm. Some strange harmonics may appear, but it's not a new law of nature. Scalar waves are hypothesized longitudinal electromagnetic waves that do not appear in standard Maxwellian electrodynamics, often discussed in fringe or suppressed science. Hutchison and others have used terms like scalar interference to describe the supposed nonlinear interactions in his setup. However, no experiment has validated the existence of scalar waves or shown how they could alter matter or gravity. Most scalar wave claims lack mathematical foundations and rely on anecdotal interpretation or alternative field theories outside peer-reviewed physics. No scalar field detector has ever confirmed scalar wave emissions in controlled EM experiments, like trying to explain a firework display using invisible dragons. Colorful language, but no measurable substance. One of Hutchison's most unusual claims is the apparent fusion of metal and wood without heat, or the softening of solid metals into a jelly-like consistency. Such transformations would require a breakdown of atomic bonding, or phase transitions not possible under room temperature EM field exposure. High-voltage fields can cause localized arcing, surface damage, or even microplasma formation, which might superficially deform surfaces. However, cold fusion of dissimilar materials without melting contradicts our understanding of thermodynamics and bonding energy. Without spectroscopy, calorimetry, or structural analysis, these anomalies remain unexplained and likely artifactual. Photos of fused plastic and metal components have been offered as proof, but independent labs have not replicated such effects, like baking a cake without heat and claiming it turned into pudding. An entertaining result, but physically implausible. Scientific validation depends on independent replication, which has not been achieved with the Hutchison effect. Multiple researchers, including those sympathetic to alternative science, have failed to reproduce the claimed effects using similar apparatuses. Hutchison's own demonstrations have not been conducted under blinded or professionally controlled conditions, raising concerns of confirmation bias, hidden mechanisms, or observer error. Even when partial setups are duplicated, no levitation or material anomalies have been reported beyond what can be explained by electrostatics or mechanical vibration. The lack of replicability undercuts any claim to scientific legitimacy. A 1990S project by the U.S. Army reportedly attempted to replicate Hutchison's results, but concluded they could not be substantiated. Like a recipe that only works in one kitchen and never again, something smells off. Despite lacking scientific credibility, Hutchison's claims have drawn intermittent interest from defense agencies and fringe propulsion researchers. Some of this stems from a desire to explore exotic propulsion or energy systems that fall outside conventional physics. Anecdotal reports suggest defense contractors reviewed Hutchison's footage, but no public program has validated or funded further development. The U.S. military has explored speculative EM propulsion methods, such as the EM drive, though with inconclusive results. The Hutchison effect remains a curiosity on the periphery, not a foundation for defense science. Classified or black project interest has been rumored, but no documentation confirms military endorsement or scientific support. Like flipping through sci-fi books in a weapons lab, not for implementation, but for imagination. The most likely explanation for Hutchison's observations is a combination of experimental artifacts, uncontrolled conditions, and psychological priming. High voltage setups can cause unpredictable electromagnetic interference, electrostatic levitation, corona discharge, and thermally induced motion. Without rigorous shielding, instrumentation, or control conditions, it is easy to misattribute conventional effects to exotic causes. Maybe levitation might result from vibration, wire suspension, or surface charge accumulation rather than altered gravity. Unexplained results are not proof of new physics, they are often signs of poor measurement. Some levitating objects in Hutchison's footage were later suspected to be hanging on thin wires or moved by localized vibration, like a funhouse mirror. It shows strange shapes, but the distortion is in the glass, not in physics. The Hutchison effect stands as a cautionary tale in the intersection of curiosity, poor methodology, and scientific rigor. Its enduring mystery lies not in confirmed results, but in unverified claims, charismatic presentation, and resistance to falsifiability. While open-minded exploration is essential in science, it must be accompanied by clear methodology, repeatable experiments, and theoretical coherence. Until these are present, the Hutchison effect is best viewed as an artifact of fringe experimentation, not a glimpse into anti-gravity or transmutation. It may inspire, but it does not yet instruct. Decades after the original claims, no scientist has demonstrated Hutchison-like anomalies under peer-reviewed scrutiny. Like chasing a shimmering mirage on the horizon, it fascinates from afar, but disappears up close.